So we're going to discuss a topic when we're discussing equilibrium about when is x considered small. So like when can we ignore x? And generally speaking, I don't like to use formulas, y'all, but I think this is a safe way to do it. In general, I want you to just be able to look at it and compare it and think, does this answer make sense or not? And then determine it from there. And generally, your intuition will guide you. But I'm going to show you two examples: one when we'll use it, and one when we won't, and one when we will. So we're going to say, generally, it's when x is within 5% of the thing you're subtracting it from. And this is after you've solved without the quadratic. Okay, so let me give you an example. Let's say we have an equilibrium equation that's 1.4 times 10 to the negative third. And you have it set up so it equals x squared over like 0.70 minus x. All right, so if x is really small, like let's say it's 0.000015 or something like that, if you take 0.7 minus that, your answer is still going to be 0.7, right? If you have $1 million and you lose 25 cents, you still got $1 million bucks. So that's why oftentimes we say, hey, let's just go ahead and pretend x is small and not even worry about it here, so we don't have to do the quadratic equation. All right, so let's go ahead and do that. In the first example, with no quadratic, we're going to assume x is small, even though this is a pretty big Ka. So I think you just end up getting a feel for it. You look at this, you're like, hey, that's a pretty big Ka. You should probably do the quadratic. But it really depends on this number. If this number had been really small, then you definitely would have done quadratic. You just end up getting a feel for it. But there's a mathematical way you can check until you get that feel. All right, so no quadratic, we end up with an answer of 0.0313 equals x. So we assume that this is 0, we solve it, and we get that this is our answer. Well, the way you check to see if it's small is compare this number to this number. Was it really small? Was it really negligible? And we want to make sure that it's within 5%. So we'll go ahead and take that 0.0313 divided by 0.070, or 0.70 times 100%, and you find out that it equals 4.5%. 4.5% last time I checked is less than 5%. So we are good, and you're okay to not use quadratic. But let's use a situation. Let's say, let's go ahead and make this number smaller. So that way, when we subtract some x, chances are it's going to be greater. So let's give another example here. So I'll use kind of the same numbers. So we got 1.4 times 10 to the negative third equals x squared over, let's use let's half it, 0.35 minus x. All right, so let's say we don't have a feel for it. We want to solve it the simple way. We solve it the simple way. We make that go to 0. And then if that's the case with no quadratic, assuming it's a 0, you find out that x is equal to 0.0221. Of course, I would end up having 2 sig figs, but let's use some extra ones for the calculation. All right, so it's 0.0221, and now our next step is to compare that number to what we subtracted it from and see if it's really negligible compared to that. So we say 0.0221 divided by 0.35 times 100%, and you find out that it's 6.3%. That means the 6.3 is definitely greater than 5%, so you need the quadratic. It's not negligible. And so then if you go ahead and solve the same problem with the quadratic, that is, you move all this stuff to one side, and I suggest, again, you always have x squared on one side, so I would move this over there, and then I would subtract it this way, so you always have a minus b, or a plus b plus c. Remember, it's ax squared plus bx plus c, and that's 0 equals that. All right, so if you get it in that format and you solve with the quadratic equation, or you use an app or something that solves with the quadratic equation or your calculator, you get an answer of x equals 0.0214. So very similar, super similar, but in multiple calculations, this could end up causing a difference in the error. So a difference in your answer. So that's the rule of 5%. It's a pretty reasonable rule. So if you follow it, you'll be fine in this class. Bye.